Hello, class. I would like to continue with what we have learned the other day about mixtures. Okay, so it will actually help to finish up the worksheet 3C. Okay, so we're back to chapter 3 again, right? Okay, about methods, about elements, compounds, and mixtures. Okay, so the last lesson was a lot about mixtures, okay, the properties of mixtures, okay, and the type of mixtures that we actually have can remember. To remember, we talk about air being a mixture, seawater being a mixture, rojak being a mixture. So there are so many mixtures around us, and they are not pure at all because it's a mix of different substances together. Now, we are going to go into specifically two types of mixtures, solutions and suspensions. Okay, so solutions, right? And suspension. So vinegar and oil salad dressing are examples of mixtures, but they can be differentiated by their properties. Okay, so vinegar is transparent throughout, while oil salad dressing is not. So you can see from here, right, the vinegar is very, very clear. Okay, it's like transparent, you allow light to pass through. But for the oil salad dressing, there are certain parts that allow light to pass through and certain parts doesn't allow light to pass through. It's not that clear as compared to vinegar. So this actually gives us an idea that vinegar is called a solution and oil salad is a suspension. So please take note, these two are known as mixtures, but we further differentiated between them as solution and suspension. Now, what are exactly solutions? Solutions are like what I mentioned, vinegar. Okay, and another very, very popular example is mixing salt with water, mixing sugar with water. Okay, so when salt dissolve, okay, the salt that dissolve is called the solute. The water that dissolve the solute is called the solvent. And we have this mixture known as the solution. So solution is a mixture of solute and solvent. So please take note, there are new things that we're learning here, solute and solvent. Okay, how can we tell whether the mixture is a solution? What's so special about solution? How do I know? Okay, so for solution, there are solutions, many solutions around us, like carbonated drinks. Okay, in fact, like Pepsi, Coke, Sassy, 100 Plus. Okay, when you open it, right, you will realize, hey, there's a lot of gas coming out. It's actually carbon dioxide gas dissolved in the water to make carbonated drink. So you can see that solution, right? Please take note. A lot of students thought that, oh, teacher, solute, right, is always solid. It's not necessary. In the case of the carbonated drink, like 100 plus, okay, the solute, right, is actually the carbon dioxide that dissolve in the water. I would say that usually solvent are usually water lah, liquid. But solute, right, can be gas, can be solid, okay, or even liquid and liquid. All right. Okay, so for carbonated drinks, the solute is actually carbon dioxide, okay, dissolving in water to give me carbonated drinks. And another example would be syrup. Okay, syrup is dissolved in water to make drinks. So you can see here it's liquid and liquid, no? The syrup, for example, mango syrup, I dissolve in water. So make a mango juice. So it's actually liquid with liquid. And dyes as well. Okay, certain dyes, different colored dyes, dissolve in water to produce a fabric dyes. Okay, like for example, I have an orange dye and mix with water. Okay, so these are all examples of solutions around us. Now, how about suspension? Suspensions, right, is an insoluble substances, meaning that that particular solute cannot dissolve. They just stay there. Like for example, seawater. So that's why we show you this example. Seawater got sand. So this sand mixed with water, right? The sand cannot dissolve. It will remain suspended in the liquid or in a gas, right? So oil spill as well. So oil when it spill with water, right? It will mix with seawater to form a suspension. Right. In the next video, right, we'll learn about how can I tell whether that mixture is a suspension.